Hi, this is Mr. Ye. Today I would like to introduce you the AP Calculus Crash Course first part. We're going to talk about how to analyze f prime of x graph. And here we got a f prime of x graph, and we're going to use the f prime of x graph to predict what does f of x graph look like. Okay, so I list some important things under the y box on the right hand side, so that makes you thinking about those are the important things that to study. So at least at here. Okay, so here we're gonna have a original function. This is f of x, and you see I use decimals to graph f of x equal to x to the fourth minus 4x squared. I did not highlight the f prime of x or f double prime of x because we're not talking about that yet. But we're going to predict what this graph will look like using the f prime of x, which is this one. If you pay attention on the left-hand side, it says this one is f prime of x graph. Okay. Now we're going to move on to go through several things to help you to analyze this. So we're going to do it as short as we can. So here we're going to say, let's pay attention to one of the things that in AP Calculus that's pretty important. Is this one. Is what is critical points? And those are also the things that is important. Critical point means when derivative of the functions is equal to 0 or f prime of x is equal to undefined. So a lot of time people forget about the undefined part, but I will tell you when f prime of x equals 0 or f prime of x equal to undefined, that means it's a critical point. So AP exam could ask you, says, where's critical point? Here you're going to say critical point occur about roughly negative 1.40 and 1.4. Now, at critical point, one of the three things can happen. So the first thing is you can possibly have a relative max, and B, you can have a relative min, and C, you can just have some type of horizontal tangent. So I'm going to write down as HT. Horizontal tangent is going to be HT. Okay, so if you're ever wondering what's HT stand for, I'm just going to say that's horizontal tangent. Now, by knowing this, we can go into identify where's f prime of x equal to 0. F prime of x equal to 0, that means when f prime of x is touching the x-axis. Okay, it's touching the x-axis. Now, where do they touch x-axis? Roughly at this point, and at this point. And if I counted my boxes correctly, because between negative 1 and negative 2, they separate to 5 intervals. So each interval should be 0.2. So roughly, that x equal to negative 414, that is going to be the, when f prime of x equals 0. So we're going to just write down as 1.4. And I can evaluate to show you where's 1.4 happen. So at first, it's going to be negative 1.4, 0, and 1.4. Okay. So if you look at the things on the right-hand side, it says f prime of x is above x-axis and below x-axis. So what does that mean? If it's above, means f prime of x is positive. I use color blue to show you. If f prime of x is below x-axis, that means it's negative. F prime of x is negative, but also means original function is decreasing, because that's what the first derivative tells me. So this part here is negative. So they see this region that's in blue is below x-axis. Actually not blue. So I'm gonna erase this. Sorry. I'm gonna use the tracer. So here it's gonna be negative below x-axis. So if it's below x-axis, this should be a negative sign. So I'm going to write down between negative infinity to negative 1.4 infinity. This one's going to be a negative sign. And between negative 1.4 and 0, and you're going to look at the original f prime of x graph. So this part is going to be blue, because we say blue is a positive. It's above x-axis. So that's going to be positive here. And between 0 to 1.4, this one is going to give me a negative, because if you see here, is a below x-axis between 0 and 1.4, and you see that x value, and that's going to be causing this part is negative. And then you're going to go to the last part is going to be above x-axis, and this is a part that is going to be positive, so this part is going to be positive as well. So that's going to tell me that it's increasing here, and this increasing here, and here is going to be decreasing, and here is going to be decreasing. So it tells me a lot of information on what happened in f of x graph. And that seems true, because they say between decreasing, I'm going to write down decreasing here, it's between negative infinity to negative 1.4, and from union from 0 to 1.4. And increasing is going to be from negative 1.4. I'm going to use blue so that way you can see the color coding difference. So increasing is going to be from negative 1.4 to 0, union from 1.4 to infinity. Okay, so those are the things that you see. And let's go back to see what the original function looked like. And you can tell this original function, at this part is going to be negative, because, sorry, negative should be in red. It's red here all the way to negative 1.4, which is kind of makes sense, because according to the original thing here, they say it's decreasing. And they say from 0 to 1.4 is also decreasing, which is right here. And the increasing is going to be in this region. It's going to be from here to here, and from here and go up, according to this, which is, it predict exactly correct. Now let's go back and look at what happened with those critical points. So according to the things on the right hand side, I told you first derivative test, if f prime of x changing from positive to negative at the value c, then x equal to c is relative maximum. So let's see if that's true. So if I went from negative to positive, it's going to be relative minimum according to the first derivative test. And you can say that x equal to, we're going to use black, we're going to say x is equal to negative 1.4, because decreasing to increasing. And there's another time x when decreasing increasing is 1.4. At those 2 points, there is a relative minimum at f of x, because first derivative test, and I will state the first derivative test, because my f prime of x change from negative to positive, therefore it's a relative minimum. And you can make it the same argument, says x equal to 0 is relative max, because f prime of x changing from positive to negative. And then you can say, okay, that's all the things I can tell. That's easier for teach me, what kind of things happened. And that should be all for this video. Good luck, and hopefully to see you next video.